This screencast is a substitute for lecture on Monday, September 23rd, 2019, for Math 102, Sections 101 and Sections 112. I will be away that day, and so this is what you get instead. So today I'm going to talk about differentiation rules, or at least in this part of the screencast. I will make another subsequent screencast with a different topic just to keep these short. And reminders for this week, this coming week, pre-lecture 4.1 is due today, meaning Monday. If you're listening to this in advance of Monday, you should be on that over the weekend. Pre-lecture 4.2 is due on Wednesday, and assignment 3 in web work is due on Thursday. OSH 2 is due on Friday just before midnight, and that one's, I think it's a more challenging and possibly longer assignment than the previous one, so you should definitely be starting that as soon as possible if you haven't started it already. But in general, I recommend you start the OSH at least the week before the OSH is due. Okay, so let's go on with differentiation rules. Four differentiation rules we're going to talk about. The addition rule, and that one is used for functions f of x that are, let's say, the sum of two functions g of x and h of x. Okay, so how do we take a derivative of a function like f if we know the derivatives of g and h? The product rule is for functions f of x that are defined as the product of two other functions. So f of x is equal to g of x multiplied by h of x. The chain rule, composition of functions, that will let us take derivatives of functions f of x that are defined by composition. So plugging h of x into g of x, where we know how to take the derivative of g of x and we know how to take the derivative of h of x, and we want a rule for figuring out the derivative of f of x. And finally, the quotient rule, this one is for functions that are ratios, those things of this form, g of x divided by h of x. And the quotient rule is really the product rule and chain rule in disguise, because these functions can be rewritten as g of x times h of x to the minus 1. And so you could use the chain rule, or the product rule, on g times h inverse, and then chain rule on h to the minus 1. Okay, so here's our first clicker question. So given that f is defined as the sum of g of x and k of x, and that g of 2 is 3, k of 2 is 1, g prime of 2 is 2, and k prime of 2 is 5, what is f prime of 2? So because there's obviously no clickering system we could use when everybody's doing this at different times in different places, I'm just going to stop talking for a moment. You can hit stop, work on it, figure out your answer, and then commit it to paper or somewhere. Write down your choice, A, B, C, D. Be sure you do that. I don't want you just sneaking by and waiting for the answer to pop up. And then we can continue in a moment. Okay, so I'm assuming you stopped this movie and have restarted it after having finished working on that problem. So let me just tell you that the answer here is 7. So I'll go through and talk about how this works quickly, because I think most people would get this one correct. So, so here we have, let's say, f of x as defined above is g of x plus k of x, and we're plugging in f of 2 into the derivative. So let's take the derivative. Now, the addition rule is fairly simple. When you have a sum of two functions, the derivative of that sum is the sum of the two derivatives. So I take the derivative of g of x and I add to that the derivative of k of x. So f prime evaluated at 2, which is what we're looking for here, is going to be g prime of 2 plus k prime of 2. And now I can substitute in values. G prime of 2 is 2, and k prime of 2 is 5, so I get 7. You'll notice g of 2 and k of 2 are actually irrelevant when your function is defined by the sum, because we don't need g of 2 and k of 2 to determine the derivative. All right, so let's move on to the next clicker question. This one is chasing down the product rule. So I'll give you a few seconds here to hit stop, think about it, do some calculations, and commit to an A, B, C, or D answer. All right, I assume you've done some calculating with the movie stopped and have come to an answer. So now I can just tell you what the answer is, because we can't go through the whole, show the histogram of answers for the whole class, because there is no whole class. Answer is 17. So there's a common mistake, which hopefully none of you fell into, but let's look at what it is. So, oops. So because f of x is now the product, it's tempting to think that the same type of approach will work here. In other words, I might hope that f prime of x is equal to g prime of x multiplied by k prime of x. And I'm not putting an equal sign in between there intentionally, because this is actually incorrect. And I'll say something in the next slides, the next few slides, about why that's incorrect. But for now, I'm just going to write down the correct form of the product rule, and that is we take the derivative of g multiplied by k, no derivative, add to that g without any derivative, and multiply by the derivative of k. So if I'm now looking for f prime at 2, I need all of these values above now. So first one is g prime at 2, which is just 2. And then I multiply that by k of x, which over here is just 1. And then I add to that g of 2, which is 3, and multiply by k prime of 2, which is 5. So that gives me 2 here plus 15 here, and I get 17 overall. Okay. Now if I'd use the incorrect product rule, which would be the product of g prime and k prime, I'd have 2 times 5, and that you may have thought 10 would be the correct answer. Not. Okay, so now I'm going to say a few words about, here's another way, or a simple way to see why the simple incorrect version of the product rule doesn't actually work. So let's say we've got a function, g of x is x, a function g of x being x and k of x being x squared. So these are two functions we know how to take derivatives of. And so let's just go through that. If f prime is really given by the product of the derivatives, which it's not, then we could write f of x as x times x prime, and then f prime of x as, first the derivative of the x is 1, and the derivative of x squared is 2x. So we get f prime is equal to 1 times 2x, which is not correct, but this is what we would get if we followed the incorrect product rule. But if you actually take the product first, you get x cubed, and the power rule says that the derivative of x cubed is 3x squared. And clearly, 2x and 3x squared are not the same function. So this incorrect product rule really is incorrect. Don't use it. Okay.